So, vanakkam. So, we will start our class on earthquake measurements. So, last class we discussed that the earthquake can be quantified. Okay, so two way. One is that qualitative way, which is called as a intensity. The another one is a quantitative way, which is magnitude. So, the magnitude we told that it depends upon the what type of wave you are considering. So, the magnitude type also changes. So, we put discussion on the different intensity scale which is available and then we have seen that there are 4 intensity scale which has a 12 level of grading the earthquake, and there is a one Japanese scale which is grading as a 7 level, there is a one RDS so which is 5 level. So, we come to the discussion with the intensity scale. So, we have to see that. Okay, so why these intensities are important? We also discussed about the isoseismal map. We also discussed that the intensity basically describe the damage due to the earthquake. So, that means if you know the intensity from the past earthquake, you can know that how much the level of damage occurred on that particular place. Okay, so we have discussed about the isoseismal map. So, basically the isoseismal map is basically like this. So, this is the isoseismal map. Soon after earthquake, so it will be released by the people. Okay, so after observation and survey. So, this isoseismal map basically give you the idea. Okay, so which are the places the buildings are damaged high level, which are the places the buildings are damaged so lesser level. So, that is what it will give you the idea. So, if you look at this particular table, if you look at this particular table, you can see that the damage percentage related to the your intensity scale. So, which means if you know the intensity scale from the old earthquake, you can assess a damage. So, where it helps basically, this will help for the prediction of how much damage can expected at a particular place if the magnitude earthquake is assumed or the magnitude earthquake is predicted or the magnitude of earthquake is estimated from the knowing the seismic source and all, which we will be discussing in detail this one. So, if I magnitude of earthquake is for example magnitude of earthquake, so we get the M as a 7 magnitude, okay, so which occurred at the distance of from your place, it is maybe the D is equal to 100 kilometer. So, if you know this isoseismal maps basically, so where that 100 kilometer comes, you can know what is the intensity you are expecting at that particular place. So, the MMI, okay, so modified Mercalli intensity scale. So, this will help you to get. So, basically this intensity measurement, okay, or quantities are useful to assess what is the damage expected in the region. We should also remember that these intensity scales are based on the past earthquake building construction in that region. So, if the similar practice is there, so it will predict very well. If there is a difference in the practice, there may be difference in the value predicted. For example, it is predicting a building damage of 70%, okay, so based on the old intensity map, but the buildings are now improved, it may vary, depends upon the building construction. Okay, so that one has to remember. So, from here we can understand that the process of predicting this kind of damage level is called as a seismic vulnerability assessment. Okay, seismic vulnerability assessment. So, by knowing the past earthquake intensity, one can say that how much damage expected for the future earthquake also by comparing the magnitude and distance, or by taking large amount of the data in the region and developing a intensity predictive relation, which is called IPE, intensity predictive relation. So, intensity predictive equation or relation you can call. So, these equations are useful to predict what is the intensity we can expect if there is a X magnitude going to occur at Y places. So based on that you can say that okay, my city going to occur like this area 70% damage, this area 50%, this area 20%, something like that you can map, which will help basically to plan a disaster management and mitigation strategy. So by knowing this, okay, if this is the status, if the area which is going to damage more than 50% given a concentration, and try to individually identify those places and try to improve the structures or demolish and retrofit the new structures. So where there is a minor level, you can tell them to repair it, otherwise when earthquake comes you will be in the trouble. So such kind of analysis, these data are useful for those kind of analysis. So now when earthquakes are occurring, it is not only with respect to the building damage, but the mostly the MMI scale or most of the other scale only describe the damage with respect to building or rails or the chimney kind of things. So they did not talk about the one more very important parameters which has been identified by the some of the researchers. Okay, so basically as I told you that I am doing research on this area. So I found that this research gap. What is the research gap? Soon after earthquake, okay, this not only it affect a building, it also affect a infrastructure. Particularly the infrastructure means roads I am talking. Why the roads are important? Soon after the earthquake, the roads are basically used to move from one place to other place and evacuate a people and then getting a medical aid to the people. So 2005 Pakistan, Indo-Pakistan earthquake, actually many people died due to the lack of the evacuation and the medical facility soon after the earthquake, not because of the earthquake, because this occurred in the very remote area of the Jammu and Kashmir and Pakistan border, where there is not much access basically. So there is no, most of the hill roads are closed due to the landslide, and then people may not able to move. So this resulted people even with light injuries or they don't have much problem because of the earthquake. But since there is no food and there is no water, there was no medical facility, people obviously died after some time. So this was the one of the main concern. Then the researchers start thinking about that it's not only the building is very important to assess the damage, there is a need for assessing the road related damage also, so that you can work out a evacuation and rescue strategy in the particular place. So in order to do that, first of all you should also need to have the damage related to road studies on that. So when we look at those kind of studies, there are very less study has been given, or even the intensity does not describe what was the road status in that particular earthquake, or road, how many roads are failed, why it is failed, such kind of studies are not there. So which was realized by myself and my team. So then we started thinking that if you want to assess a seismic vulnerability of the building, okay, you need to basically do the intensity scale and take a intensity predictive equation and then assess the same. The similar way, if you want to concentrate on the seismic vulnerability of the road, so that you can identify which are the roads are damageable and what percentage it can damage. So you can plan your evacuation and as well as the mitigation strategy for the soon after the earthquake, particularly the disaster. So management and planning can be taken up, okay, soon after the earthquake if you have the good transportation connectivity of the roads. Okay. So when we go back and see the intensity scale, there was not much discussion was given in the road. So which was actually understood and then studied. So this is the typical example. Soon after the earthquake you can see the roads, you can see this is the one of the road basically. So you can see this road, so how it's badly damaged, people only cross by walking, you cannot go. This road you can see that the partially collapsed, but still there are 50% of roads are available. Here you can see that in between the bridge and the road got cracked. So here also the another damage, like this there are a lot of damages. So the researchers like actually this scale was basically developed by me. So what we did basically, so we collected the information from the historic report where and all road got damaged and photo of those damages, and try to compile from the historic data. So, like with respect to magnitude we collected and distance of that particular road from the epicenter has been collected, and try to get a photo of that road, and then the damage description. These data are compiled. Okay. So, why this is very important? Because if you want to do the transportation planning after the earthquake for the evacuation and the mitigation and then the handling of the medical patients and treatment and all. So, the road network is very important. So, that is why we try to understand that how the previous earthquakes are caused damages, how such damages are scaled. Okay. So, we noticed that most of the previous earthquake damages are described in the form of MMI scale. Okay. So, then based on the data what we collected, okay, so we collected large amount of the data and try to group the data and try to categorize that, then we made a 5 category of the damages. So, the level 1, okay, which is called as a road damage scale. So, this is the new intensity scale purposefully developed to describe road damage due to earthquake, and which will help for the seismic vulnerability assessment of the road network. Okay, so that after the disaster you can know that which are the road networks are not damaged, how you can evacuate the people, how you can treat the people, how you can move the necessary goods, which road you can use, what traffic condition. So, everything can be simulated on that. So, we based on the data available, so we described the entire RDS scale as a 5 category. Since the road things are coming basically the felt and then the any other description which is comes up to 4, 5, 6 in the MMI scale may not be required actually. Okay. So, that is why we discarded the preliminary part of the scale. So, we started with the level 1, the level 1 RDS is like intensity scale, road damage scale level 1. So, this is the damage from the many minute cracks and 1 or 2 moderate cracks not exceeding the 20 mm width, and slight damage shoulders and footpath. Very little repair work is usually necessary to restore the road for full traffic. That means, if you do a small bit of work you can use the road immediately. So, those kind of roads are categorized as RDS 1. So, similarly the RDS 2, so where there is a minor repairs are required, and then but there was a damage was slightly larger than the RDS 2. So, similarly RDS 3 where the part of the road is settled and blocked, but still you can access the road. So, this kind of things happens mainly due to the liquefaction and the fault rupture and then the landslide kind of Then the fourth was like it is almost like rendered completely useless, and loose soil debris found on the road. The load layers are rushed by the, so damaged road can be used only to the smooth walking or something like that. That is the fourth. And fifth category is it is not possible to use at all. Okay, that is the fifth category. So, we categorize this definition we are given first time in the world to describe how the road damage and relative intensity scale, which is called as a RDS. Okay, this description. So, let us see what is the comparison with the previous same road, how it is described. So, we noticed that the previously the whatever we talk as a 1 which is not even affected, but it was given the intensity scale up. So, 12. Okay. So, basically it is given the intensity scale up 12. So, and then similarly for the other intensity scale whatever the damage description you can see. So, 9, 10, 6, 5 something like that. So, so based on this new definition of the road damage and the data which we have collected up to like around 25 earthquake which had a photos and damage description particularly with respect to the road, where the magnitude, distance, photos, damage description. Then, so this is the data, you can see basically this data. So, you can see the magnitude, distance and depth of the earthquake which is between, then hypocentral distance and then reported MMI scale and that particular place. So, this you can see there are many. So, based on the damage description on the photo, we reclassified these damages based on the RDS scale previously discussed. So, this is the new proposed RDS grouping of that. Okay, this new intensity has been assigned. So, after assigning this, we did some statistical analysis. So, we did some statistical analysis and see how the past reported MMI scale for the road goes with the magnitude and distance, how the new scale goes with the magnitude and distance. So, this is the basically the graph of the MMI scale with respect to the moment earthquake magnitude. You can see it was scattered, there is not much trend has been observed. So, the distance you can see some trend, but not so much uniqueness you can see with respect to the MMI scale. So, which was previously used to describe the road damage, even though this scale is not suitable for the road. Okay. Then the RDS scale. So, we find that there was a unique way of grouping the data. You can see the earthquake magnitude for the same damage road, but in the RDS scale, redefinition of the RDS scale. So, similarly again you can see with the distance. So, now we combined both distance and magnitude. So, this is like again the MMI scale with hypocentral distance. So, RDS scale with hypocentral distance. So, the magnitude and distance combination, okay, RDS and magnitude with hypocentral distance combination, you can see there is a unique trend can be obtained from this. So, which says that, okay, so if you know the magnitude and hypocentral distance, basically you can predict what is the road damage can be expected at a particular location if there is a road. So, this is the unique trend we find, and which was actually the first findings, okay, where. So, we did a lot of combination of the statistical analysis and try to see which form basically gives more less error and more reliable prediction. You can see these are the several equations we developed, and this is the equation 12, 13, 14, where the magnitude and epicentral distance combination, okay, where the data which gives a very good reliable prediction of the RDS. Okay, you can see the R square value and then the range of damage you expected, magnitude range and the distance range. So, only thing these combinations are working for the different segment of the distance, you should use a different formula, okay, or different formula coefficients which is given. It is not throughout the distance. For example, 1 to 30 meter one setup. So, 49 to 125 1, 190 25. So, in between there is no data, but when you predict this, obviously it will take care of this one. So, by using this you can basically predict a road damage expected in that region. So, if you know the road damage expected in the particular region, basically you can use that for assigning the. So, these are all the roads which need to be improved before earthquake, so that the road can be used for evacuation or not, or these roads may get failed due to this kind of earthquake, which will lead to the problem in supplying the relief material as well as the evacuation process. So, that conclusion can be arrived. So, even after identifying the damageable road and non-damageable road, so you can identify what are the location hospitals are there. So, what are the places people are affected. So, by integrating with the satellite and live data, one can do a traffic simulation and modeling and management. So, that is where these road damage scales are help you. So, this is actually the unique study. As I told you that apart from teaching this subject, I also work on the problem which is in large extent the research solution can be given to that problem. This is such kind of one study. So, which is available in my website, where this paper was published on 2013. So, it was accepted soon after we submit without much problem, because this concept itself nobody was brought into the study so far. Okay. So, there are many people now they use this RDS scale and try to do the identify the road network which is available for the evacuation and how they can manage a traffic management. So, here you should remember that we only collected the existing data and used. We assumed that all the roads are in the similar category. Okay. That means the soil and road sections are similar, but which is not true on many cases. So, which need to be studied in the future. So, which will also fetch you get this kind of best models, okay, so by enhanced data and numerical analysis, which will further improve the development in this area. Okay. So, the RDS scale also one of the intensity scale which is specifically designed for the use in the roads. Okay. So, specifically designed to use in the roads to describe damage of the roads due to intensity. So, all these intensity scales you can see that it is based on the damage occurred in the particular place. So, this RDS can be also used to notify the road damage and classify the road the earthquake caused road damages and grade them. Apart from giving the MMI, we can also use RDS along with the previous MMI scale. Okay. So, these are all based on the descriptive this one. There is no much earthquake measurement is gone. Whatever you are talking as a waves, different type of wave which does not go into this one. So, because of that this kind of non-instrumental measurement has some kind of limitation. So, what are those limitations? Basically it is a based on the past historical records. The assessment and use of this is not straightforward and may lead to incorrect result due to the inevitable bias. So, for example, when there was developed the first intensity map during the 1950, the construction style and construction practice is completely different from as on today. So, using up that to predict your today's scenario, one has to be careful. So, unlike like RDS scale was very recent one, but most of the intensity scales are very old. Okay. And also that time the construction and practice will be different. So, the recent studies Ambrasi indicated that for a 3 active region around the world, limiting up catalogs are used in the hazard analysis to a short period time and may grossly overestimate or underestimate the ensuring the hazard. So, the intensity value purely use and predict a hazard at particular case, it may overestimate and underestimate because of the these are all non-instrumental recorded data, there is no proper measurement and the damage description also qualitative which depends upon the person to person and case to case it keep varying. So, the overestimate underestimate is the function of whether the observation period was exponentially quiescent or energetic epics. Okay. So, these are all the some of the things we have to remember when you talk about this kind of non-instrumental record. But still since olden days there is not proper earthquake instrumentation. So, the damage based description scale data intensity scales are very well needed for better prediction of the hazard in the particular region for the future earthquake. That is why even though today the magnitude is there, people still use intensity. So, now from this class you will understand that when you use intensity, when you describe magnitude. Okay. So, the magnitude is actually qualitative way of getting somebody reported you can use. So, the based on the damage somebody reporting you should use intensity. You cannot interchangingly use, since the people who are reading the newspaper doesn't know, that doesn't mean that we should interchangingly use and tell wrong things to the people. So, with this we will close the intensity class. So, we will move forward to the quantification of the earthquake by magnitude in the next class. So, thank you very much for watching this video. So, we will see you in the next class. Thank you.